kind of getting into the point where we are going to do most everything on the calculator in the next few chapters, so we're going to start getting ready for that now. So population proportion, we were talking about those the past, several days. We used them yesterday in our review. When we're talking about a population proportion, what are we talking about?
P-hat.
P-hat. So how do we find P-hat?
X over N.
Alright, so first, just an example, refreshing what P-hat is. So in July 2008, we had a poll asking 1,783 registered voters nationwide whether they favored or opposed the death penalty for persons convicted of murder. 1,123 were in favor. Obtain a point estimate for the proportion of voters nationwide who are in favor. So, all I'm asking for is the P-hat, which we just said was X over N. What's our X?
153.
What's our N?
173.
And if we divide those, we get 0.6298. Okay. So, trying to understand our point estimate a little bit. Does this say that in the entire population, most people would favor the death penalty? Not necessarily. It's possible, but do I know for sure? No. So, does it mean most people are in favor? Not necessarily. Do you think a different sample would give a different percentage?
Yeah.
Yes. Each sample would likely be different. Okay, so what we have been doing is calculating the probability of something happening. Okay, that's all this previous step. We're using the normal table to find the probability of something happening. This is kind of switching and making us aware, okay, we realize that if I did this poll 75 different times, I probably would get 75 different proportions, right? Each sample is going to be different. So if I'm trying to really depict the original population, I'm going to have a range of values and say, okay, I think the true population falls between 49 and 75% or something like that. We would need a range of values because we know every time we pick a different sample, we'll get a different answer. So that leaves the idea for a confidence interval. So confidence interval is just an interval of numbers based on a point estimate. These are not terms that I am going to put on your test as a vocab or a matching section or anything. These are just words you're going to hear me say. So confidence interval is just a range of values. Level of confidence is basically how accurate do we think it is. So it's the expected proportion of intervals that would contain our parameter if a large number of different samples were obtained. Okay, that sounds really confusing, but if I said I am 95% confident that it falls between, let's just say I'm 95% confident my number falls between 10 and 20 for whatever my sample might be. What that's saying is if I went out and found 100 different samples, 95 of them would fall between 10 and 20. So 5 times out of 100, I might have a number that's smaller than 10 or bigger than 20. But 95 times out of 100, the sample would fit in this window. Does that make sense? So, in general, the more confident you are, probably the bigger your range of values is going to be. Okay, if I'm going to have it fall in here 95% of the time, I'm going to have a fairly wide range. If I want it to fall between 3 and 4, that's a very small window, right? So that's not going to happen very often. is a point estimate. That's like our p-hat. And then we'll have to add or subtract some margin of error. So it's going to be centered around our p-hat. It'll be like p-hat minus the error and p-hat plus the error. So p-hat is the center. We'll add or subtract a certain amount to get our range of values.
It's like our standard deviation.
So we talked about like with originally, measuring standard deviations. You could be above or below. So it's just kind of above or below with the margin of error. That margin of error is telling us how accurate we are. So the last thing here just kind of illustrates what I already mentioned. If we're going to be more confident, we get a wider window. Okay. If we have a bigger sample, that will allow us to be more accurate, so we would decrease our error. Okay, bigger samples, less error. Standard deviation. If you're talking about something with a high standard deviation, a big standard deviation is going to make a bigger window of error. Okay, because we know standard deviation is how spread out. If our data is really spread out, we're going to have a lot of error with that. If it's all pretty much the same, we'll have a small amount of error. So today we are talking all of this related to p-hat. So I'm taking every opportunity I can to refresh the things we need to know about p-hat. So if I'm talking about p-hat, what is our criteria?
NP 1 minus P is greater than
And the second one? The sample is less than 5% of the population. The mean for p-hat is just our population proportion. Standard deviation for p-hat is our square root of p times 1 minus p over n. This is what we already know related to p-hat from yesterday.
Isn't on the end greater than, isn't it greater than, not less than, on the second criteria thing?
No, you want it to be smaller than that.
Yeah, the first one has to be greater than 10. So the n times p times 1 minus p is a greater than 10, but our sample is less than 5% of the population. That's what we were. I think you guys did it right yesterday. We had it up here. Okay. The formulas. So these are directly off your formula sheet. I do want you to look at your formula sheet though and see how it's written. So it's the first bullet, and it writes it as a single formula. It has plus and minus. Whereas I separate them out to show you the lower value and the higher value, okay? But all of this stuff is things that we have done. We can find p-hat, we know n, z alpha over 2, we did those at the very beginning of chapter 7, so that'll be the one thing we need to refresh today. Our criteria still has to be met in order for this to work. So these are the formulas. Again, I'm going to show you how to do them, but most of the time we're just going to use our calculator. So I'm going to show you how to do it on the calculator as well. What this means, so the meaning of a confidence interval is we are whatever percent. So it might be 90%, 70%, 85%, whatever percent confident. The true value is between the lower and upper limits. The margin of error is what we are adding and subtracting. So notice both of these are centered around p hat. Like the picture I drew before, p hat is the middle. To get the lower, you subtract your error. Get the upper, you add your error. So the error is that z alpha over 2 times the square root p hat 1 minus p hat over n. So the error is just how much we add or subtract to get our window. Okay. Let's just try some. So back to this first example we had. So the 1,123 were in favor. We had asked 1,783. Now I want to get a 90% confidence interval for the registered voters who are in favor. So in order to do this, we have to check our criteria and we need our p hat. What did we get for our p hat in example 1?
0.6298.
Okay, the one thing that's different here, did I give you the p for the original population? No. So this is what we do when we don't have any information about the whole population. We're trying to base it off the sample. So when we're checking our criteria, we are going to use our p hat value. So our n, 1783, times our p hat, 0.6298, times 1 minus p hat, has to be greater than 10. So I get 415 something. So that is definitely bigger than 10, so that works. Is 1783 less than 5% of all voters? So I don't know all registered voters. I can't actually check it, but I'm just going to jot that down to make a note that I did acknowledge it. I'm looking at that. We know there's a lot of voters out there. We're going to assume this is less than 5%. So now, in order to do the confidence interval, we need p hat, which we have. We need our z, and we need n. What is my n in this case?
173.
So the thing that I need to find is my z alpha over 2. And that is probably the hardest part of this. We did these back at the beginning, but the z alpha notation is a little bit opposite of what we think. If I want a 90% confidence interval, that means I want 90% of my points to fall in the middle, right? How much is left for each end?
25.
So there's technically 2 z values that would go with this. I only need the positive because the formula, we already include the minus in the formula. So I need this z value right here. If I'm looking at that z value, my table tells me how much falls below it. So how much is below this? If 5% is to the right, that means 95 is to the left. So remember when we were looking at our tables and reading inside? So 95 is the probability. That's the number inside this table. So you are looking for the closest you can get to 0.95 in this table. So in the center of the table, looking for 0.95, as close as we can get. 1.645. Because it falls in between 1.64 and 1.65. I want everybody to make sure they can find that on their table and understand that. We're good with that? That's probably the hardest part of today. So now, the formula. Look at your formula sheet. This is what you have in front of you for a test. Okay, so it tells us to make our confidence interval. We are doing p hat plus or minus z alpha over 2 square root p hat 1 minus p hat over 8. So we're just plugging in. P hat was plus and minus z alpha over 2, 1.645, square root of p hat, 1 minus p hat, over n. When you type this in, you are getting a starting and a stopping point. So type in the minus first. So we'll do 0.6298 minus 1.645 times the square root. And I think I gave you guys a blank slide after this, if you need more space. Once you type in the first one, you can hit second enter and just change that first minus to a plus. So this first one is like it's called our lower limit or a lower bound. This one's the upper. But I think it's easiest just calculate it and get this window. So what this means, this was a 90% confidence interval, right? So it means we are 90% confident. What was this measuring?
True value.
Mm-hmm. True value. Or in this case, it was the
People in favor.
people in favor of the death penalty. Is between 0.611 and 0.6486. Okay, if you didn't say of people in favor of the death penalty, that's fine. I just want you to understand, we are 90% confident that the real proportion falls between these two numbers. If I went out and got 100 different samples, I would expect 90 of them to fall in this window. That is a confidence interval. Any questions there?
What was your reason again? Why we didn't, the CA2, what was your reason again for not doing 0.95?
because we wanted the middle 90%. So that means there's 5% on each end. Other questions? Let's look at another one. A Gallup poll found 54.9% of those surveyed considered the amount of federal income tax they pay to be fair. Gallup reported the following survey. So results were based on telephone interviews, random sample of 1,016 national adults aged 18 and over. For results based on the total sample of national adults, one can say with 95% confidence the maximum margin of sampling error is 4%. Okay, we're trying to make sense. This is what real polls look like sometimes, and trying to understand what that says. They reported 54.9%. So does that mean it is 54.9%? No. We are 95% confident there is a window between certain values. Okay, so let's think about what those would be. It said the error was 4%. So this 54.9 is like my p-hat, 0.549. That's the center. If that's within 4%, that means your true value could be 4% below or 4% above, right? So 4% below would be, and 4% above,
5, 8, 9.
so we're adding and subtracting 0.04. Okay, so that's my confidence interval. Interpret it means we are 95% confident. The true value is between 0.509 and 0.589.
Maybe 5 points. No, that's a percent. No.
So I want to show you how to do this on the calculator. Do you want me to do the next one? Do you want me to do one by hand again and show you the calculator? Do you want to see one more by hand before I just... Are you guys confident that you can plug numbers into the formula? Okay. Let's talk about the calculator, because most of the time that's what we're going to do on these. So a survey asked 800 16 to 17-year-olds in the U.S. if they had ever used their cell phone to text while driving. Of these, 272 indicated they have. Obtain a 95% confidence interval. Okay, the things that your calculator can't do is check your criteria. So we need to check n times p times 1 minus p. So we need our p-hat, don't we? So p-hat is x over n. What's my x?
272.
N?
800.
So check my criteria. My n, 800, times p, 0.34, times 1 minus p, has to be greater than 10. And that's 179.52, so that works. Would 800 be less than 5% of all 16 and 17-year-olds?
Mm-hmm.
So I'm just going to say it's less than 5%. So my criteria is good. On your calculator, so if you want to do this by hand, or on the calculator, you go to Stat, Tests, and then you have to scroll down until you see capital A. So it's called a 1 proportion z interval. Okay, we only have one p hat, so it's 1 proportion. We're looking for using the z value, so it's a 1 proportion z interval. Then you have to type in x, n, and c level. What was my x? 272. What is my n? My confidence level is the percent, so 95%, we'll type in 0.95. And notice it does give us our p hat below, the 0.34 is what we got. You can use all the decimal places, we can round it if we want, so we get 0.3072 to 0.3728. Didn't have to interpret that time, but it was 95% confidence interval, so we're 95% confident the real proportion falls between these numbers. Did everybody get that to work? No. Stat test letter A. Let's look at what happens in this same example if I change my confidence level. No, you're doing z test, we need z stat test. Letter A, 1 proportion z interval. Okay, so determine the effect on the margin of error by increasing the level from 95% to 99%. So, we're still going to stat test A. My x and my n did not change, so those were, the difference is my C level is now going to be 0.99. So how does this interval compare to our original one? It's wider, isn't it? My lower number is smaller, my upper number is bigger, so this is a wider interval, which means it increased the error. Which is what I talked about before. If you want to be really, really confident, you have to have a wider range of values. If I dropped my confidence down to like 70%, what do you think would happen to my interval? It would get a lot smaller if I only had to be 70% confident. So as your confidence goes up, your window is going to get bigger. All right. Let's try to work backwards. I want to find the point estimate of population proportion. So I'm trying to find p hat this time. The margin of error for the confidence interval and the number of individuals. So there are 3 things I'm asking you to find. The 3 things that you're normally given in the problem. Oh, sorry, not in X, the number with the characteristic. Okay. What we know is our lower bound. So the interval began at 0.051. It ended at 0.074. What has to happen in the middle?
P.
The middle is our p hat. How do you find the middle?
Add the two together.
Okay. So to find our p hat, we're just averaging those. And we get
0.065.
the error is the amount you add or subtract. So we have error on two sides. We have error here. We have the error here. So to find it, all you have to do is subtract two of those numbers. So we could do like our p hat minus the lower limit. Zero, 1, 1, 5. All right. Let's think about how we find x.
Would it be plus or minus or just?
No, it's just the error is the amount you add or subtract. So we know that we get p hat by doing x over n. What is the p hat? Found p hat to be 0.0625. I'm trying to find x. And it told me n was 1,120. So to find x, we just multiply over the 1,120. And x turns out to be 7. So if we kind of have an understanding of how confidence intervals work, we can work backwards to find those things. Any questions there? There is one final thing that we need to cover today, and this is, again, directly off our formula sheet. So it's basically how big of a sample do I need to create? Okay, if I'm wanting to get a good confidence interval, I have to make sure that I'm including enough in my sample. I am not going to show you where this formula comes from. It's a bit confusing in the why. It comes from the confidence intervals, but it works backwards to tell us the number we would have to have in our sample to have a certain confidence level. And if we want to be more confident, we would have to have more in our sample. Since we are talking about the number we're using, we'll always round it up. You know, if I'm talking about surveying people, I can't survey 20.5 people. I would have to round up to 21 people. So we'll always round up. This directly from your formula sheet. So if you look in chapter 9, we have the confidence interval column. The column to the right is the sample size. So this is that first formula there. And we have a second one. The difference is this first one we use if we have p hat, if we have some survey data. The second one we use if we don't have a p hat. Right? And both of those are on the formula sheet. So we'll try one of each of those and then I am done. So a sociologist wants to determine the percentage of residents of America that only speak English at home. What sample size should be obtained? So I am looking for the sample size. She wishes her estimate to be within 3 percentage points. So that 3%, that is my error. That's how far off we can be. So 3% would be 0.03. With 90% confidence, assuming she wishes to use the estimate obtained from the census in 2000 of 82.4%. So I have prior data. That is my p hat. So because I have a p hat, I need to use the first formula. So that formula says p hat 1 minus p hat times z alpha over 2 divided by the error squared. The only thing I don't have is z alpha over 2. But we can figure that out. In fact, we've already done this one today. 90% confidence. That means I need the middle 90%. So how much is left for each end? So we need this z here so that 95% falls below it. Some of these, if you look at your normal table, in the bottom right, it does, or sorry, bottom left, it tells you some z alpha over 2 values, not all of them, but it tells us for 90, 95, 98, and 99, those are some of the most common. So you are welcome to use that, and it tells us for 90%, what is it? 1.645, which is what we looked up last time. Same thing you would get if you looked up the 0.95 in the middle of the table. So now we plug this in. P hat 0.824 1 minus 0.824 times z alpha over 2 1.645 divided by the error 0.03 squared. And I'm just putting all of this in my calculator. Let's get 436.04. Anybody need me to look at the calculator? So we always have to round up here. If I only talk to 436 people, is that technically enough?
No.
No. So we have to always go up, 437 people. In order to be able to create a confidence interval that is within 3% and 90% confident.
We need to write the part about creating.
Yeah. If I were doing the same thing, but I did not want to use that prior estimate, so I'm not using the census from 2000. So then we look on our formula sheet, we are talking about the sample size needed, but there is no prior estimate, and it tells us n is 0.025 times z alpha over 2 divided by the error squared. So still the same confidence level, so my z alpha over 2 is 1.645. My error is still the 0.03. We're just plugging into a different formula. And what happens to the number of people we have to survey?
It goes much up.
Yes. If you don't have any prior data, it is going to increase the amount of people you need. Any questions for me? So, we're doing this like we had the last two chapters. Today I taught 9.1. Tomorrow I'll teach 9.2. Then Monday is going to be a work day for chapter 9. Okay, so I'll go ahead and give you the packet now. It will not be due until Tuesday.